having a literal as 1, so you have to make an entry again into our literal table. So I'm going to write here in the literal table 1. Okay, that means this 1 is defined in the first literal pool, whereas this 1 we have encountered after the LTORG statement is now is in the second pool, okay, which is given by this, which starts at location 3 in the symbol table. Now I do not have an associated address, so we will fill it later on. Now coming back here, for this I will have to write literal, and it is at location 3. Now A is a label that we have encountered. Whenever we encounter a label, I have to write it into my symbol table. Because it is already been written, I'll only have to associate the location counter value, which after the execution of this statement, it obviously would be 206, because this statement would have a length of 1, after which it becomes 206. I will enter the associated address there, and if you see it is ADS1, that means I am declaring storage for 1 memory operand, so the length becomes 1. Okay, and what do I write here for DS? Okay, I am not going to write any equivalent intermediate code because it is a DS statement. And finally I encounter end. Now if there were no literals in our program, okay, we don't have to write any intermediate code, but there are literals in our program, okay, and we have encountered those literals after the LTORG statement. So at location 207, okay, because this occupies only one memory location, what you need to do is you have to look at all the literals that have been used in our program, okay, after the encountering of an LTORG statement, okay, and we have to associate addresses with them. So there has only one literal that has been encountered in our program after the LTORG statement, and that is why we are going to associate address to only this literal. The obvious address associated will be 207. So looking at our literal here you will have it at what? Location 207. Okay, now we are not going to, we have encountered the end statement, so we are not going to have a new pool started because the program has finished, it has ended. Okay, so these are only the two literal pools that have been generated for this assembly program. And like I mentioned before, if there are literals, okay, you are going to write them as a series of DL, 01 statements, okay, where the first where you are not going to have a first operand and you are defining a constant 001. Okay, now so at the end of pass 1 we've got our intermediate code, we've got our symbol table for all the symbols that have been defined in the program, we've got our literal table, we've got our pool tab, that is tells us how many pools, literal pools are there for our program, in which case there happens to be two literal pools, okay, one which begins from location 1 in the literal table and the second one which begins at location 3 in our literal table. Okay, now with the help of all this we are going to generate our equivalent machine code. So for the first statement it would be writing the location counter value, writing the instruction opcode 04, writing the first operand. For the second operand it says refer the literal which is at location 1 in the literal table. Okay, so this is 1, okay, and the address associated it is 203. So I will write here 203. Okay, next is 201. Okay, what is the instruction opcode over here? It is 05. This is 1. It tells us to refer a symbol in the symbol table that is at location 1. So if you look at the symbol table, at location 1 you have a symbol A defined and its associated address is 206. That is why we have 206. Okay, what is this 202? We have basically defined, we having the instruction opcode 01. The first operand is 3. See the literal at the second, okay, and the associated address is 204. So we will write here 204. Okay, next comes 203. At 203, okay, I am just having a constant called 5, and at 204 I am having another constant called as 1. Okay, these are for the literals. Okay, at 205, okay, the instruction opcode is 2. The first register is 1. Literal at the third is 1, and its associated index value is 207. So I will write here 207. 206 is your just, you have declared space, and at 207 you have to write the constant called as 1. So we have written 1. Constant is here. So this is 1. This is how you are going to do processing of an LTORG statement. If in this program, okay, you are not encountering the LTORG statement at all, okay, in that case all the literals will be processed after end, and there will be only one literal pool, okay, and you will have only two literals defined in the literal table, which would be 5 and 1, because 1 is repeated here. Because we have encountered an LTORG statement, that is why we are having two literal pools in our program. If this LTORG statement is not there in our program, then all the literals will be processed at after the end. So you will have only one literal pool, and you will have two. For this program you will have only one literal pool, and you will have only two literals defined, okay, and you will have to write all the equivalent intermediate code after the end statement as a series of DL units.